So the RC filters, we can look at them as simple voltage dividers for AC current, and they are voltage dividers with a frequency controlled resistance. Both of the topics I've already covered in my previous videos. So let's look at them a bit closer. First of all, filters. They filter out some frequencies. So this is the input frequency for the both of the schematics or filters. The input signal. We can see I'm using a sweep generator, which is constantly varying the frequency. And just to mention it, both of these schematics are originally included in the falstad.com/circuits simulator. Under the circuits menu you could see the passive filters, and these are the high pass and low pass filters. So let's take a closer look. We have a variable frequency input signal which has the constant amplitude 5 volts, and we are passing that signal through a filter and another one. So the first one is high pass filter, which lets high frequencies through and blocks the low frequencies. And the other one is a low pass filter, which lets low frequencies through and blocks the higher frequencies. As we can see, it's not very sharp. It is slowly starting to block the lower frequencies and slowly starting to let through the lower frequencies, and vice versa. So as I mentioned before, we could look at them like voltage dividers. We have one resistance here and the other one over here, and this resistance or the capacitor can vary its resistance depending of the frequency that we are inputting over here. So as I talked in the frequency controlled resistor video, the resistance of the capacitor over here and over here depends on the input frequency. The higher the frequency, the lower the resistance over here and over here. So if these are resistors, then let's pause it for a moment. Okay, it still simulates the varying frequency. Okay, so we have paused it at low frequency right now, lower frequency input, and we can see that high pass filter doesn't let low frequencies through, but the low pass filter lets them through. Why is that? We can see that the capacitor and the resistor are in different places on different schematics, and if we look at them, then over here during low resistance or low frequency we get high resistance, which means this resistor has a high value and that resistor has a lower value. We could calculate that value, but it's not the point of this video. And so this one has a higher value than this one, and that's why the output voltage, which is actually the voltage drop on the resistor over here, is lower. And the higher the frequency, the lower the resistance over here, thus the higher resistance would look like over here, and on higher resistance we get higher output voltage. It would be probably easier to look at it on the low pass filter though. So once again we have the low frequency over here, and during low frequency we get high resistance here, and on the higher resistance we get higher voltage drop, which we can see over here. Now if I let the sweep generator to go on and achieve the higher frequency, which is about here, then we can see that at higher resistance the capacitor's resistance, higher frequency, the capacitor's resistance goes lower, and at lower resistance we get lower voltage drop, which we can see over here also. And also over here we have lower voltage drop, which means higher voltage drop over here, and we can see that in here as well. But it's probably easier to look at RC filters. Look first the low pass filter, which is a bit more logical. And very similarly the RL filters work, where we use inductance, and since inductance works opposite to capacitance, then on high pass filter the resistor would be here and the inductor would be here, and vice versa. So if the explanation was a bit difficult to understand, then one should take a look at the voltage divider video, and also the frequency controlled capacitor resistance video, which explained these concepts, which I haven't seen outside my classroom. So thanks for watching.